Right, so we're going to solve rational equations today. So a rational equation is just a bunch of polynomials written in fraction form, and then we need to solve them. So for problem number 14 out of the textbook, it wasn't assigned, but I'm going to do this example to give you an idea because the assigned problems are very similar. We have 4x over x plus 4 plus 3 over the quantity x minus 1, and that's set equal to 15 over x squared plus 3x minus 4. Now, normally whenever we deal with fractions, we need to have a common denominator, or sometimes we'll call that the lowest common multiple. Now, the way that we find the common multiple, or the lowest common multiple, or the least common multiple, depending on what textbook you read, is that we take all the factors of all the fractions, or all the denominators, and find out which ones they have in common, and then we raise those to the highest power. So the first thing that I would need to do is I think that quadratic expression x squared plus 3x minus 4 can be factored. So I'm going to factor that first. It's no accident, but I think it's going to be x plus 4 minus 1. So in your homework, most of these problems are going to kind of be rigged, so that way you can find the common denominator easily. To verify my suspicions, I'm going to draw a box and multiply x minus 1 times x plus 4, and sure enough, it does equal x squared plus 3x minus 4. So then my lowest common multiple, or my common denominator, would be x plus 4 times the quantity x minus 1. So I need to make sure that every fraction has that in the denominator. So for my first fraction, if I multiply the bottom by x minus 1, that fulfills the lowest common multiple. And remembering, whatever I do on the bottom, I have to do on the top. I repeat that same process on the second fraction, but I'm going to do x plus 4 on the top and bottom, because my lowest common multiple is x plus 4 times the quantity x minus 1. So I need to make sure every fraction has in the denominator x minus 1 times the quantity x plus 4. Once I've done that, I can focus on the numerator because the denominator is already equal, right? So I'm going to solve for x, or values for x, that makes the statement of the numerators true. So I'm going to write 4x times the quantity x minus 1 plus 3 times the quantity x plus 4 equals 15, and then solve for x. So this is just basic algebra review, kind of, but we're going to push the 4x through and the 3 through the parentheses, and then solve. When I'm done, I'm left with this nice little quadratic of 4x squared minus x minus 3 equals 0. Truthfully, I combine like terms of the x raised to the first power, but I probably didn't need to. So to solve a quadratic equation that's set equal to 0, I could factor it, or I could solve for by using the quadratic formula. The quadratic formula always works, but factoring is a little easier. You could write out like this AC method, which means you take the first and the last term, multiply them together, and then figure out what two numbers I multiply to get that. But when I add those same two numbers, I'll get the B term. So A times C is 4 times negative 3, which gives me negative 12. But I need to rearrange those numbers in a way that when I add them, they equal negative 1. Negative 4 times negative 3 also equals negative 12, but negative 4 plus 3 equals negative 1. Now, there's an old method that you could use that's kind of a T factoring method. I like to use the grid method, which is a little easier. And so what I'm going to do is I'm going to replace my negative x with negative x, or negative 4x plus 3x, and then I'm just going to write all four terms in the grid. If I factor out the greatest common factor from the columns and the rows, I should factor out the quadratic expression. By doing that, I end up with 4x plus 3 times the quantity x minus 1, and so that whole quadratic expression factors to x minus 1 times the quantity 4x plus 3. Setting both factors equal to 0 gives me my possible solutions are x equals 1 or x equals negative 3/4. I'm almost done, but the last thing that I need to check is for extraneous solutions. Remember that these are rational expressions, so one of my solutions, when I plug them in, could cause a problem with the lowest common denominator. Notice that every one of the fractions had the lowest common denominator of x plus 4, times x minus 1. The reason that might become a problem is because when I plug in my solution, I'll get some number over x plus 4 minus 1 plus another number over x plus 4 times x minus 1, and that should equal 15 over x plus 4 times x minus 1. Well, the problem that we run into is that one of our possible solutions, x equals 1, will not work. Because if I take x equals 1 and I plug it into the denominator of any one of the rational expressions, what happens is I'll get 1 minus 1, and that becomes 0. And so then my denominators become undefined. We can't have 0 in the denominator. So x can't equal 1. And the reason for that is because it makes the fractions, or our ratios, right? Ratio is a fancy word for fractions, undefined. So we would say that that's the 0 in the denominator, and we can't have that. So our only real solution that we can consider to be a solution to this rational equation is x equals -3. And that's pretty much it. That's all you have to do for all of your homework.